Hello, this is a video on writing chemical formulae and it's suitable for use with the IGCSE chemistry specification. Now before we start writing chemical formulae, I thought it would be quite good to look at actually what the formulae represent. So let's have a look at a few. Right, so here we've got, let's look at these first four over here. You'll see water, which you should be familiar with, and then we've got three other compounds that you may or may not be familiar with. Now the second one is nitrogen dioxide, the third one is carbon dioxide, and the final one here is carbon monoxide. And the first thing I'd like to point out is that all four of these compounds are made just using non-metals. And when we have compounds which only contain non-metals, quite often the name of the compound tells you a little bit about the formula. Now water doesn't tell us very much, but even someone with a very basic knowledge of chemistry knows that water is H2O. Now this one, NO2, is called nitrogen dioxide. And so if I say to someone, oh, we've got nitrogen dioxide here, that should immediately fire a sort of shot in their brain that, okay, we've got some molecules here, and each molecule contains one atom of nitrogen and two atoms of oxygen. Likewise, if I say to someone, we've got carbon dioxide, that means each molecule of carbon dioxide contains one carbon and two oxygens. And the final one, carbon monoxide, that means each molecule of carbon monoxide contains one carbon and one oxygen. Now, that's all very nice and handy when you've got compounds made up of non-metals. What about if you have a compound made of a metal and a non-metal? Sodium chloride, for example, magnesium oxide, magnesium nitride. How do we know what the formulae of these compounds is going to be? Well, I'm afraid it's not. You can't just use the name, because you can see here that magnesium oxide, well, in this unit of this chemical, you can see we've got one atom of magnesium and one atom of oxygen. So sometimes magnesium goes together with other elements in a 1-to-1 ratio. But sometimes it doesn't. When magnesium reacts with nitrogen and forms magnesium nitride, magnesium, well, in this unit here, you get 3 magnesiums for every 2 nitrogens. So why is that? Well, we're going to look at how to write the formula of compounds which have metals and non-metals in them. And I'm not going to explain anything about the bonding within the compounds, but I am going to explain to you how to write the formula using valency tables. So, here is a valency table, and what I've done is I've split the substances that we could be looking. Well, I've sort of split them into two. On the top, we've got substances which are mainly metals, and on the bottom, we've got things that are non-metals. And you can see we're talking about them having different valencies. And I'm not going to explain to you what a valency is at this point. All I'm going to say is you use the numbers that we assign to the substances to help you write the formula. So I'm afraid I'm not going to tell you actually what valency really means. I'm just going to tell you how to use it. Now, at this point, I think it would be worth pointing out that it would be a good idea to print out these valency tables for you to use while we're doing the video. Okay, so in the video I'm going to show you how to write the formulae, but it would be very handy if you had this valency table in front of you. So if you have access to a printer, print it out, okay, or maybe you could take a screenshot and have that on your phone while you're working through this on a computer or a tablet. So let's write some formulae. Right, so hopefully you've now got a valency table, and we're going to just take 3 compounds to start with. And the first compound is potassium bromide. So what I would like you to do is to find potassium on your valency table. And you should see that potassium has a valency of 1. Now find bromide. Bromide should be in the lower of the two tables on my previous screen. Bromide also has a valency of 1. And the formula of potassium bromide, therefore, is KBr. Now, magnesium oxide. Notice I've not told you why it's KBr. I'm going to ask you in a minute. Magnesium oxide. Okay, magnesium. Have a look at its valency. It has a valency of 2. Oxide has a valency of 2. Magnesium oxide is MgO. And hopefully now you can spot a pattern that if the two components have the same valency, we just say there is one of each of them in the formula. So K and Br are both 1, so we have KBr. Magnesium and oxide, 2 and 2, so we have magnesium oxide. Iron 3 nitride. Now this little 3 is quite interesting because iron has 2 possible valencies, either 2 or 3. And when you're given a compound's name, helpfully you'll be given what the valency actually is. So I already know, without even looking at the valency table, that iron is 3. And if we look at nitride, wonderful, you should find it is 3. So the valency of that is Fe(N). Not a compound I've come across very often, okay, but for this section here, the golden rule is if they have the same valency, it's a 1-to-1 ratio in the formula. Okay, you may want to write that down somewhere if you're taking notes off this video. Hopefully that's reasonably straightforward, and so let's press on. Let's do something slightly trickier. Okay, again I'm going to ask you to consult your valency tables for these 3 compounds. So potassium has a valency of 1. Oxide has a valency of 2. Oh dear, they're not the same, so we can't apply the rule that we were using before. So I'm going to introduce a second rule to you. If the formulae are different, when we write them, I beg your pardon, if the valency of each component is different, what we do is we swap over the numbers when we write the formula. So I'm going to write a swap there, so 2 and 1 down there. So when I write this out, I say that we have 2 potassiums. The little number after indicates that that 2 belongs to the element that came before it. So K2, we've only got 1 oxygen there, 1. Now that might appear a little bit confusing. So let's have another go. Well, let's have a go at 2 more examples. So barium and iodide. So if we can find the barium in our valency table, it's at the top and it's got a valency of 2. Iodide has a valency of 1. Okay, so what did we do last time? Well, they were different, so we swapped them over. And now let's write the formula. So we always start usually with the metal. So Ba, barium is a metal. We've only got 1 of those, so we don't write a 1. And then I2. And that's an important point I make almost by accident, that if I don't write a number, that implies I just have 1 of that element in the formula. So I haven't written a number after barium, therefore there's 1. I haven't written a number after oxide, so that means there's 1. So in 1 unit of potassium oxide, I've got 2 potassium atoms and 1 oxide. In 1 unit of barium iodide, I've got 1 barium and 2 iodides. Now you might think, I'm feeling quite confident, so why not pause the video and have a go at aluminium sulfide on your own and see if you get the right answer. Right, I'm going to start now. So aluminium, we're going to find the valency of aluminium, and it's 3. And sulfide, which is just S, has a valency of 2. Okay, so what did we do if they were different? We swapped them over. So now we write out the formula, starting with the metal. So we've got 2 aluminiums, 3 sulfurs. So we write Al2S3. Now when you start getting good at these, you generally don't write out this step here. You can do that in your head, okay? But I tend to do it when I'm teaching this, so people can see how the numbers are swapping over. You might choose to do this in your head, or you might choose to carry on doing this on a piece of scrap paper while you're doing your formulae in lessons or practicing them at home. Now my next slide has 6 or 7 formulae that you can test yourself on. So they're using the 2 rules that we've used thus far. First rule is if the valency of each component is the same, you just have one of each atom in the formula. And the second rule is if the valency is different, you swap the numbers and then write the formula from the swapped numbers. Okay, so the next slide I will write the answers down, but I will not talk them through. I said I wasn't going to talk them through, but I think I might as well talk while I'm writing. I'm just going to do them quite quickly so I can fit the video into the 15-minute slot that I get on YouTube. So here we've got 2 of the same valencies. So we've got CaS. Aluminium has a valency of 3. F has a valency of 1. Okay, let's swap them over. So we've got 1 up there, 3 down there. So we get AlF3. Iron 3 oxide. So iron, it's already told us has a valency of 3. Oxide, let's look that up. It's got a valency of 2. So we swap them over again. So the 2 comes up here and the 3 comes down there. So we've got Fe2O3. Barium chloride. We've got barium. Find that on the periodic table. That's got a valency of 2. Chloride, actually you're not using a periodic table, you're using a valency table, ignore that. So just have a look on the valency table. So barium's got a valency of 2. Chloride, valency of 1. Swap them over. 1 comes up there, 2 down there. So that's BaCl2. Lithium iodide. Here we've got lithium. I'm struggling to use my pen now. So lithium has a valency of 1. Iodide has a valency of 1 as well. They're both the same, so I'll have lithium iodide like that. And aluminium sulfide. Aluminium has a valency of 3. Sulfide has a valency of 2. We swap them again because they're different. So the 2 comes up to the top, the 3 goes down below. Okay, so that means aluminium, we've got 2 of those, and sulfide, we've got 3 of those. And that was a little bit pacey, but hopefully you paused it before, had a go at it yourself, and then you can see how I'm working, swapping them over when they're different, and just using one of each when they're the same. Part 2 of the video is to come.